Imagine for a moment you're trying to figure out if an email in your inbox is just spam. That's one type of AI at work, doing a pretty straightforward job of prediction. Now, shift gears. What if you asked an AI to compose a heartfelt poem, maybe a Shakespearean sonnet, or even a unique piece of music that truly moves you? How then do you even begin to grade that? How do you assess something so creative, so subjective, so well new? Welcome to the deep dive. This is where we take a stack of your sources, articles, research, our own notes, and really try to extract the most important nuggets of knowledge and insight. Our mission today is to cut through the complexity, give you a shortcut to being well informed about a crucial and I think often overlooked aspect of the AI revolution. Today, we're taking a deep dive into the fascinating and often surprisingly difficult world of evaluating generative AI models. Specifically, we're looking at large language models, or LLMs. We'll explore why grading these, let's call them creative AI students, is fundamentally different from traditional AI. We'll look at the unique challenges it presents and the cutting-edge methods and tools being developed to tackle this new frontier. Why does this matter to you, our listener? Well, LLMs are no longer abstract concepts, are they? They are already woven into our daily lives. Drafting emails, summarizing reports, generating art, assisting with customer service, it's everywhere. Understanding how they assess their strengths, their weaknesses, their potential pitfalls, it really empowers you to use them more effectively, to critically evaluate their outputs, and maybe even glimpse the future implications of this powerful technology. It's about gaining that knowledge quickly but thoroughly, getting those aha moments, and hopefully not feeling overwhelmed by just the sheer volume of information out there.
It's truly a pivotal area, For the entire AI landscape, the better we get at evaluating these models, the more confidently we can deploy them, especially in increasingly critical applications. It moves us beyond just understanding what they can do to understanding how well they do it, and critically, how reliably they do it in the real world. That confidence in their performance, well, that's what really allows for broader adoption.
Right, so to begin, it feels like we need to distinguish between different kinds of AI, especially when it comes to assessing their performance. What's the core difference between, say, that spam filter we mentioned and an AI writing a sonnet?
Yeah, that's a really fundamental distinction. On one side, you have what we call non-generative or sometimes predictive AI.
Mm.
Think of this as your diligent detective or maybe even like a digital fortune teller. Its primary job is to analyze existing historical data, usually a massive data set of past information, and then predict or classify or make a decision based on patterns it's learned from that data.
So a classic spam filter would be a perfect example, wouldn't it? It's seen millions of emails, it's identified common characteristics of spam, and then when a new email comes in, it just makes a judgment, spam or not spam. It doesn't create a new email, it just classifies an existing one.
Exactly. Or consider an image classification system.
Yeah.
You feed it a new photo, and it analyzes features to predict this is a cat or this is a dog. It's about making a judgment on existing data, not inventing new data. And the correctness in these cases is usually pretty straightforward. Either it correctly identified the cat or it didn't. We often call this the ground truth.
Uh-huh.
The definitively correct answer we're comparing against.
And that's where the fundamental shift occurs, right? Generative AI, on the other hand, that's your artist, your musician, your storyteller. It also learns patterns from vast amounts of data, just like predictive AI. But instead of merely making judgments or predictions about what is, it creates something entirely new and original. The output is open-ended, often highly creative, and literally didn't exist before the AI generated it.
Exactly. And what's truly fascinating here is that creative leap. We're talking about an AI that can compose a brand new song in the style of your favorite artist, a piece of music that never existed before. Or it could generate photorealistic images of faces that belong to no real person, or maybe even a novel solution to a complex problem. This fundamental shift, moving from deterministic, clear-cut answers to nuanced, subjective, and potentially limitless outputs, it changes the very nature of correctness.
Yeah.
It means we often don't have a single ground truth, that perfect human-created answer to compare against.
It's like moving from grading a student's answer on a multiple choice test to evaluating a poem or a painting they created from scratch. The evaluation rubric is completely different.
Absolutely. It's a whole different way of thinking about good.
That distinction seems absolutely fundamental, and it really helps clarify why grading these models is such a challenge. And within this fascinating world of generative AI, we're going to narrow our focus today specifically on large language models, or LLMs. If generative AI is the broad umbrella term, maybe like vehicles, then LLMs are a specific type of generative AI that specialize in language, like cars within the vehicles category.
And these are the models that are truly revolutionizing how we interact with text and information every single day. Think of models like ChatGPT, Google's Gemini, or Bard. They're not just classifying text, they're generating incredibly human-like text, drafting essays, emails, creative stories, summarizing incredibly long documents, or answering complex questions with remarkable fluency. Understanding these models, how they work, and especially how they're evaluated is just crucial for navigating our modern digital landscape because they're becoming ubiquitous, really unavoidable in many ways.
Now, you might think evaluating an LLM is just about looking at the core model itself, like, checking the engine of a car. But the truth is, it's far more complex than that. Our sources talk about a complex LLM block or an entire ecosystem where many different components interact. It's like you use the analogy of a complex orchestra where the LLM is maybe the main conductor, but many other instruments play crucial roles.
That orchestra analogy really captures it well, I think. If you're only evaluating the conductor, you're definitely missing the entire performance. To produce truly reliable and high-quality creative outputs, all these different components need to work together perfectly, in harmony. So let's maybe break down these key components that form this LLM block. First, you have the pre-trained model itself. This is the foundational LLM you choose to start with, sort of like selecting the main engine for your car. The initial choice here is critical, as it sets the baseline for everything else that follows.
Okay, so that's the raw power, the core brain, if you will. But then you mentioned data sources. What are those exactly?
Right, so data sources are external pieces of information or context the LLM can pull from in real time. Imagine your AI student being able to instantly look up facts in a giant, constantly updated library, maybe even accessing things that weren't in its original training data.
Ah, okay. So it's not just what it learned initially.
Precisely. This is especially crucial for something called retrieval augmented generation, or RAG. That's where the LLM gets specific, up-to-date information to help it generate better and more accurate answers. For example, an LLM answering a question about current events would pull info from a live news database through these data sources, ensuring its response isn't outdated.
That makes a lot of sense. Okay, what's next in the orchestra?
Next, we have prompt templates. These are essentially pre-written, structured instructions you give to the LLM. They help ensure consistency in how requests are made, which is vital for reproducible results. So instead of just saying, write an email, a template might specify, write an email to recipient name about topic with a tone, and make sure to include key points.
So it's like giving the AI clearer direction.
Exactly. This guidance dramatically influences the quality and consistency of the output. It channels the LLM's creativity in a specific intended direction.
And then there's memory, which is a concept I've always found particularly intriguing when it comes to AI. How does that function within an LLM block, and why is it so vital for evaluation?
Memory allows the LLM to remember past parts of the conversation and interactions, building context over time. It's why if you ask an LLM about your favorite color and later in the same conversation ask, what about that color makes you like it? It can seamlessly connect that color back to your previous statement.
Ah, so it keeps track of the dialogue.
Yes, it maintains continuity in the dialogue, which is crucial for applications like chatbots or personal assistants, where you need sustained, coherent interaction.
Yeah,
Evaluating memory means assessing how well it maintains that context over longer interactions.
makes sense. And then come the tools. What do tools let the LLM do?
Tools basically extend the LLM's abilities by allowing it to use external systems. It's like giving your student access to a calculator, maybe a dictionary, or even the internet itself through an API. For example, an LLM could use a tool to check current stock prices via an API, or generate an image through an external service, or even run a piece of code to solve a complex math problem.
Wow, okay, so it can interact with the outside world in a way.
In a controlled way, yes. This allows the LLM to act on information and capabilities far beyond its initial training data, making it incredibly versatile.
Right. And you also mentioned agent control flow. That sounds complex.
It can be. This is essentially how the LLM can intelligently try different approaches to a task until it gets a good result. Think of a diligent student trying various problem-solving methods until they find the right one for a complex coding challenge.
Yeah.
The LLM might generate code, test it using a tool, find it doesn't work, and then iterate, trying a different approach until the code functions correctly. It's sort of an internal loop of trial and error to achieve a goal.
Okay, like refining its own process. And finally, guardrails. These sound important.
Absolutely crucial. These are vital safety mechanisms that act as filters. They step in before the LLM's output reaches the user. Their job is to prevent a generation of harmful, inappropriate, or sometimes factually incorrect content. A guardrail might prevent an LLM from responding to a dangerous query, or it might flag an answer for human review if it detects sensitive content that could be problematic. They're absolutely crucial for responsible deployment.
Got it. Safety first.
Definitely. So, you see, in traditional AI, evaluation was often mostly about tweaking that core model itself to make it more accurate. With LLMs, the paradigm shift is much bigger. It's about making sure all these different components, the pre-trained model, data sources, memory, tools, guardrails work together perfectly. It's about orchestrating the whole orchestra, not just tuning one instrument.
And that multi-component complexity makes robust evaluation exponentially harder, I imagine.
It does. But it also allows for incredible versatility and depth in applications. It's a trade-off, but one that truly unleashes immense potential for what AI can achieve.
So we've laid the groundwork defining what LLMs are and all the complex pieces that make them up, the whole orchestra. But now let's dive into the challenges. What are the actual hurdles? Because evaluating this creative genius's AI sounds incredibly complex. Where do we even begin with those challenges?
You're right, it's definitely a whole new ballgame. Let's start with what we might call the textbook problems, as they relate directly to the very material our AI student learns from and how we assess its learning. First, there's often a significant lack of data for evaluation. While LLMs are pre-trained on massive internet datasets, they can generate text for incredibly specific or niche tasks where maybe you, as the user or developer, don't have much existing data to use as a benchmark.
Right, so you ask it to write something unique, but you don't have many examples of what good looks like for that specific thing.
Exactly. The key insight here is, without diverse, specific benchmarks that truly reflect a unique task, it's incredibly hard to know if an LM is truly excellent or just good enough for that specific, novel, creative output you asked for. How do you grade the poem if you have no other poems like it?
And this leads directly into data contamination, which sounds like a huge concern for reliable evaluation.
It is. LLMs are trained on these vast, often untracked data sets, effectively reading almost every book in the world, or at least huge chunks of the internet. The problem is, some of those books might accidentally include the very test questions you're using to evaluate them.
Oh no, so it's seen the answers before the test.
Potentially, yes.
Yeah.
If the LLM has already seen the answer or something very close to it in its training data, it will perform artificially well on that test, making your evaluation completely unreliable.
It's like if a student is given a surprise pop quiz, but they secretly read the exact questions and answers the night before their perfect score isn't a true reflection of their actual knowledge.
Precisely. It's a critical flaw in measuring genuine skill or generalization ability. And for creative outputs, we also face the challenge of limited reference data. For tasks like generating a unique poem, a novel story, or maybe a brand new problem solution, there often isn't just one correct answer. It's inherently subjective.
So it's hard to collect examples of good.
It's incredibly difficult to get high-quality, diverse reference examples for these outputs because of their subjectivity. If your reference data is too small, or maybe biased towards one style, it might miss many good outputs the LLM could produce, simply because they don't match your limited examples.
Imagine you're trying to grade a student's painting, but you only have one example of a good painting to compare it to. What if the student's painting is fantastic, but just very different from your one example?
Exactly. The sheer scale of LLM training data combined with the creative, subjective nature of the output makes curating perfect evaluation datasets incredibly hard.
So that's the data side. Tricky stuff. Moving on, we hit what I was thinking of as the mysterious mind problem. Model complexity and decision-making. LLMs are often described as vast black boxes, right? It's incredibly hard to understand why they make the decisions they do. They deliver these amazing outputs, but you can't easily get them to explain their creative process or trace the thousands of tiny decisions that went into it.
That's a great way to put it. The multitude of choices in their development, from how they're trained, which data they prioritize, to how they're customized or fine-tuned, means that exploring and interpreting their internal behavior is an extremely resource-intensive task. And the crucial takeaway here, if we don't understand why an LLM makes a particular decision or generates a specific output, then true accountability and effective debugging become incredibly challenging.
Especially in critical applications where you really need to trust the accuracy and reliability.
Absolutely. It impacts our ability to truly trust the system if we can't understand its reasoning or lack thereof.
Okay, moving on to some of the tougher challenges. I know bias in AI is a constant concern. How does that translate into what you call the unfair grade problem when we're evaluating LLMs? What does that look like in practice?
Yeah, it's a significant technical challenge in evaluation.
Hmm.
LLMs, unfortunately, tend to pick up and sometimes even amplify biases present in their massive training data. This can lead to outputs that are unfair or discriminatory, even if unintentionally.
Can you give an example?
Sure, an LLM trained on biased historical text data might generate job descriptions that consistently associate certain professions with one gender over another, just because that's what it saw in the data, despite not being explicitly programmed to do so. The challenge for us in evaluation is actively detecting these subtle biases in the generated text, which can be hard, and then effectively measuring whether our mitigation techniques, the things we do to try and reduce bias, are actually working.
So you need to evaluate the fix as well as the problem.
Exactly. This is all about ensuring the models we build and deploy are fair in their outputs, which requires rigorous, ongoing evaluation focused specifically on bias.
Then we face the test versus reality problem. Generalization to real-world scenarios. Benchmarks, standardized tests, they're useful, but the real world is messy and unpredictable. A model that performs beautifully in a controlled test environment might struggle with real-world nuances, slang, sarcasm, or just unexpected situations it wasn't trained on.
That's right. It's like a student who aces a driving test on a closed course, but still struggles with navigating rush hour traffic in a busy city. There's a gap.
The real world is harder.
That gap between theoretical performance on a benchmark and practical application in the wild is a critical hurdle in deploying LLMs responsibly. We need evaluation methods that can bridge this gap and provide confidence that the models will perform reliably and robustly in unpredictable real-world contexts, not just in a lab setting.
And of course, there's always the potential for bad actors. The sabotage problem,
Yeah.
security concerns.
Yes, LLMs are unfortunately vulnerable to what are called adversarial attacks. These are sneaky, specially crafted inputs designed to trick the model into generating wrong, misleading, or even harmful outputs.
How does that work?
It can involve subtly manipulating the input text in ways humans might not notice, or even poisoning the training data over time to alter the model's behavior in malicious ways.
Wow, so the evaluation needs to catch these tricks.
Ideally, yes. But current evaluation methods aren't always great at catching these sophisticated attacks. They're often designed for specific known vulnerabilities, and attackers are always finding new ways. It's a continuous area of research and concern.
Like an arms race.
A bit like that, yes. This highlights the critical need for continuous vigilance and proactive security measures throughout the entire AI development and deployment lifecycle. As LLMs become more integrated into critical systems, ensuring their robustness against malicious attacks and unintended vulnerabilities is paramount for widespread trust and adoption.
Okay, finally, we face what I was thinking of as the art critic's dilemma problem. Subjectivity and evolving methods. Evaluating creative outputs is inherently subjective, isn't it?
Deeply subjective. What one person finds brilliant, another might find mediocre. There's often no single right answer when it comes to creativity or even just helpfulness sometimes.
Like arguing with a friend about whether a new song is a masterpiece or just noise. There's no objective truth to appeal to.
Exactly. And on top of that subjectivity, new evaluation methods and metrics are constantly emerging in the research community. This makes establishing consistent long-term evaluation practices quite hard. The goalposts keep moving.
So the way we judge is changing too.
Precisely. And imagine trying to build a universal masterpiece detector for all music, let alone for AI-generated tracks. It's just not feasible. This raises an important question. How do we establish consistent evaluation practices when the very rules for assessing creativity are constantly shifting, even for us humans?
Yeah.
The tools and rules for judging art are always evolving. And the same applies to LLMs. Understanding this inherent subjectivity helps you, the listener, approach AI-generated content with a critical, nuanced perspective, rather than expecting absolute perfection or a single correct answer that simply might not exist for many tasks.
So given all these profound challenges, the data issues, the black box problem, bias, real-world gaps, security, subjectivity, how do you actually put a grade on this creative output from an LLM? It's clearly much, much more nuanced than, say, a typical math test. It's like being a teacher evaluating a student's essay. You probably have different grading approaches depending on what you're trying to assess.
Absolutely. That's a great analogy. Let's break down these different evaluation types. First, the simplest is binary evaluation. This is essentially a yes, no, or pass-fail judgment. Did the student answer the question correctly? Is this essay acceptable or not?
Like checking if an email is spam or if a piece of content is appropriate, inappropriate.
Exactly. The pros are that it's easy and fast. But the big con is that it completely lacks detail. It doesn't explain why something is good or bad, just whether it meets a basic threshold.
Okay, so a setup from that.
Would be categorical evaluation. This offers more than two options, allowing for more nuance. Think of it like a multiple-choice question on a survey. Is the sentiment of this text positive, neutral, or negative? Or on a scale of 1 to 5 stars, how good is this essay? Or maybe assessing toxicity levels on a predefined scale.
Right, gives you more granularity.
It does. It provides more detail than binary evaluation,
Yeah.
allowing for a spectrum of responses. But defining those clear, distinct, and meaningful categories can still be hard, and interpreting the results can be complex depending on the specific task.
Okay, what if you want to compare different AIs?
Then we often use ranking evaluation. This is like asking a teacher to rank 5 essays from best to worst based on specific criteria, like clarity or creativity. It directly compares the quality of multiple outputs or models, often based on human preferences. For example, ranking different summaries of the same document by relevance or readability.
So you know which one is better relative to the others.
Precisely. It's excellent for identifying the best options among several, which is great for model selection or comparing different prompt strategies. But it's resource intensive because you need multiple items to compare and doesn't give an absolute score for each one, just a relative ranking.
And if you do want that absolute score,
Then you turn to numerical evaluation. This is where you assign a quantitative score. The essay scored 85% for factual accuracy or got a coherence score of 0.7. These can be single numbers or more complex aggregated scores based on various metrics.
the pros seem obvious. It's objective, easily comparable across different models or versions.
Right. But the con is that numbers alone might not capture all the subtle qualitative aspects, especially for truly creative or nuanced tasks. A high score doesn't always mean good in a human sense.
So how do you capture those subtle qualities?
For that, we often turn to text evaluation. This is akin to the teacher's red pen comments, those detailed notes in the margin. Here, human experts provide detailed feedback, critiques, and explanations in written form. For instance, a subject matter expert might verify the factual accuracy of a generated research summary with detailed notes explaining why a particular fact is incorrect or perhaps misleadingly presented.
Ah, the qualitative stuff.
Exactly. This provides rich qualitative insights that numbers might miss entirely. The drawback, however, is that it's very time-consuming, inherently subjective. Different experts might focus on different things, and very hard to scale if you have thousands of outputs to evaluate.
Makes sense. Is there a way to combine these?
Yes, and that leads us to multitask evaluation. This is like grading an essay with a holistic rubric, where you combine multiple judgment types. You might have a numerical score for content accuracy, text comments for creativity and style, and maybe another numerical score for grammar and fluency, all rolled into one assessment.
Kind of the best of both worlds.
Potentially, yes.
No.
It provides both quantitative and qualitative insights, offering a more complete picture of the LLM's performance across different dimensions. But it requires careful design to make sure the different parts work together meaningfully, and it can be quite resource-intensive to implement effectively.
Okay, so those are the types of evaluation. But what about the specific metrics? What are we actually looking for when grading these LLM essays? It's like the specific criteria on the teacher's rubric.
Precisely, and these metrics vary greatly depending on the task the LLM is performing. To start, there's lexical similarity. This is basically like a vocabulary check. How similar are the words used by the LLM compared to a human-written reference text?
And how do you measure that?
We use metrics like BLU, Rouge, and Meteor. Think of them as sophisticated tools that calculate the overlap in words or sequences of words. BLEU focuses more on precision, how much of the AI's output is found in the reference. Rouge focuses more on recall, how much of the reference text is captured in the AI's output. Meteor tries to combine both with some linguistic smarts.
So they tell you if the AI is using the right words.
Generally, yes. They're great for seeing if the AI is using the right terms or mimicking a particular style based on word choice. They're good for quantitative comparison against a reference. But importantly, they won't tell you if the output sounds natural, is grammatically correct, or makes logical sense. They just look at word overlap.
Okay, so how do we check for grammar and flow?
For linguistic quality, that's exactly what we're looking at. Ensuring that text sounds natural and coherent. This measures how fluent, coherent, and grammatically correct the generated text is. Metrics like BLERT, which is a more advanced deep learning-based metric trained to predict human judgments, are used here. And of course, direct human evaluation is often crucial for assessing fluency and coherence.
You also mentioned perplexity earlier.
Yes, perplexity is another common metric here. It indicates how well the LLM predicts the next word in a sequence, based on the words that came before. A lower perplexity score is generally better. Think of it like how surprised the model is by the actual next word in a text. Less surprise generally means it has a good grasp of language patterns and grammar.
But does low surprise mean high quality?
Not necessarily in a human sense.
Yeah.
Perplexity doesn't directly measure human-centric qualities like relevance, factual accuracy, or safety. A model could have low perplexity but still generate nonsense or harmful content. It's just one piece of the puzzle.
Got it. Then we have task-specific metrics. These seem pretty straightforward.
They are. They essentially check, did the LLM actually do the job we asked it to do? Did the essay actually address the assignment? Did it summarize correctly, answer a question accurately, translate the passage correctly?
Example.
Sure. An exact match metric might be used for question answering, did the LLM produce the exact right answer string? REGI is very common for summarization. Did the summary capture the key points? And BLEU, again, is often used for machine translation quality compared to a human translation. These are highly focused on the specific outcome expected from the AI for that given task.
Okay. And crucially, safety and fairness. How is that measured?
This is the no offensive or harmful content check. It's often a combination of things. It involves human reviewers meticulously checking for harmful language, bias, or inappropriate content. And it also uses specialized automated tools, often classifiers themselves, trained to detect things like hate speech, toxicity, or personal identifiable information. It's about ensuring the AI acts responsibly.
Right. And we also need to make sure it's not just making things up, the groundedness check.
Exactly. This fights against hallucinations, as they're often called in the AI world. It's checking for factual accuracy and consistency with real-world information or provided source documents.
How do you check facts automatically?
It's challenging. It might involve integrating external fact-checking tools, connecting the LLM to trusted knowledge bases it can query, or comparing its output against provided source material, like in ARGI systems. And very often, it requires extensive human evaluation of factuality, especially for complex claims. This is super important for domains where accuracy is paramount, like legal or medical applications.
Absolutely. What about the user experience?
That falls under user-centric metrics. We need to ask, is the user actually happy with the output? This measures how helpful, satisfying, and engaging the generated content is for the end user. Examples include running user surveys. Was this response helpful? Tracking task completion rates. Did the user achieve their goal with the LLM's help? And looking at overall user engagement metrics, like how long people interact with the AI or if they refine their queries. This moves beyond just technical correctness to real-world utility and satisfaction.
Makes sense. And finally, a big one for these creative LLMs, diversity metrics, because sometimes they can get repetitive, right?
They definitely can. Beyond just quality, we often care whether the LLM can produce a wide range of varied and interesting responses, not just the same kind of thing over and over.
You know, it reminds me of that time I tried to use an AI to write a catchy jingle for my pet, and it just kept giving me the same 3 rhyming words. Super annoying.
Exactly. That's where these diversity metrics really come into play. They help ensure the AI's output isn't stale or predictable. Metrics here include distinct N. This counts how many unique phrases, like sequences of N words or, example, distinct trigrams, are present in the output. A higher number generally means more lexical variety. Entropy measures the unpredictability of the LLM's output statistically. Higher entropy suggests more diverse and less formulaic text.
And you mentioned self-BLEU. How is that different from regular BLEU?
It's a clever twist. Instead of comparing the LLM's output to a human reference, self-BLEU compares different pieces of the LLM's own generated text to each other, usually generated from similar prompts. A lower self-BLEU score is better here, suggesting that the LLM produces more diverse responses across different generations rather than repeating itself.
Interesting. Any others?
There's MAUVE, which is a more cutting-edge metric. It compares the statistical distribution of words in the generated text to a large collection of human-written texts to see how well it mimics the richness and variety of human vocabulary.
So, trying to sound more human in its variety.
Essentially, yes. It's one of those metrics that really helps researchers push the boundaries. And lastly, coverage measures how well the LLM's output includes various words or concepts from a given reference set or topic space.
You have to be careful with diversity, right?
Absolutely. It's important to remember that high diversity doesn't always mean high quality. You could have very diverse garbage. The goal is usually a good balance between diverse, creative output and output that is also relevant, accurate, and coherent for the task at hand. Often, combining these automated diversity metrics with human judgment on quality is the best approach to truly understand an LLM's creative capabilities.
Okay, wow. So you've got all these different ways to grade all these specific metrics. But how do you actually implement all of this effectively to keep your AI creative genius on track? Because it's clearly not just a one-time test. It sounds like a continuous process.
That's a critical point. You absolutely have to think of it continuously. The evaluation process for LLMs typically falls into two main phases. The first is pre-production evaluation. This is all about getting your AI student ready for the big test before it starts its real job out in the wild. This involves choosing the core foundational model, designing the most effective prompt templates, maybe fine-tuning the model on specific data, and configuring all those components in the LL block we talked about.
It's like a teacher preparing a student for a national writing competition, guiding them on topics, structure, style, giving them practice runs, setting the stage for success before they go live.
Exactly. You're doing the setup work and initial validation here. And then, once it's out there being used, we move into in-production evaluation. This is about continuously monitoring the LLM's performance after it's been deployed in real-world scenarios.
So after the writing competition, the teacher observes how the student's writing is actually received by the audience, checks if it's still effective and engaging over time, maybe looks for drifts in quality or unexpected issues.
Precisely. This is crucial because real-world usage patterns, new types of inputs, or even drift in the underlying data sources can expose unexpected behaviors or cause performance degradation over time. The iterative nature of LLM development, where models and their surrounding components are constantly being updated, absolutely demands evaluation at every single stage of its lifecycle, from initial design through deployment and ongoing monitoring.
Can we walk through an example maybe to
Right.
make it more concrete?
Sure, let's consider a real-world example to illustrate these challenges and the need for ongoing evaluation in practice. Imagine a large media company. They want to use LLMs to identify trending news topics, a process that's currently done manually by editors, which is incredibly slow and resource-intensive. The LLM tool they envision needs to do several things: sift through tons of news articles, social media feeds, maybe reader comments, automatically find patterns and identify topics that are heating up and cooling down, analyze sentiment, are people talking positively or negatively about these topics, extract keywords associated with each trend, and then display all of this information clearly on a live dashboard for their editors to use.
Okay, that sounds like a complex but valuable tool. What are the evaluation challenges there?
Well, let's say the company needs to compare at least two different LLMs, maybe one general-purpose model and one fine-tuned on news data, to see which performs best for this specific task. And they need to process, let's say, over 1,000 articles and countless social media posts daily. On top of that, they need to track performance using at least two key evaluation metrics for each model, maybe accuracy in identifying trends and the quality of the extracted keywords.
Right. This immediately presents significant practical challenges. First, scalability. You need an evaluation system that can handle that massive volume of text input and the generated outputs from both models, potentially across multiple metrics, every single day.
It's like needing to grade thousands of complex analysis reports every day from multiple students all at once without a massive team of human graders. The scale is daunting.
Then there's validation. The system must accurately and consistently calculate those performance metrics, trend accuracy, keyword quality, sentiment analysis across this huge, constantly changing volume of data. You can't just eyeball it and hope for the best. You need robust, automated processes you can trust.
And finally, reusability and efficiency. The ideal evaluation system should be easy to use repeatedly. Calculating your chosen metrics should require minimal effort and customization each day or each time you tweak a model or prompt.
You certainly don't want to have to build a new complex grading system from scratch for every single day's news cycle or every time you want to test a small change.
Exactly. It needs to be efficient and reusable to be practical.
So to tackle these complexities, scale, validation, efficiency, and ensure your AI student is actually delivering value, there are some key strategies. Maybe we could call them the teacher's best practices for LLM evaluation.
That sounds like a good way to frame it.
Okay, first one seems obvious from our discussion. Employ multiple evaluation metrics. Don't rely on a single score. For that media company's trend analysis, you wouldn't just look at whether it found a trend. You'd also look at how well it summarized it, the sentiment accuracy, the keyword relevance.
Right. Using a combination of metrics like fluency, coherence, relevance, factual accuracy task completion, maybe even diversity or safety scores depending on the application, gives you a much fuller, more comprehensive picture. This multifaceted approach provides a much richer understanding of the LLM's strengths and weaknesses than any single number could.
Second big one, incorporate human judgment. Even with the most sophisticated automated tools, human insight seems absolutely vital, especially for these subjective and creative or nuanced tasks like judging the quality of a trend summary.
It really is indispensable for many aspects. Now, to make human evaluation more reliable and less purely subjective, it's best practice to use multiple human judges, like having several teachers grade the same essay independently. And then you should conduct inter-rater reliability checks, using statistical measures like Cohen's kappa or Fleiss kappa, to ensure those judges are generally agreeing on their assessments. If they wildly disagree, your guidelines might be unclear, or the task might be too subjective even for humans to agree on.
Can you scale human review?
You can consider crowdsourcing platforms for certain types of human feedback, which helps get wider perspectives and achieve scalability. However, managing quality control and ensuring consistent application of guidelines with the crowd can be challenging in itself. It's not a silver bullet.
Okay. Third best practice.
Leverage domain-specific data for evaluation. You need to evaluate your LLM using datasets that are specific to your industry or the type of real-world scenarios it will actually face.
So if your AI student is writing for a science fair, you'd grade them on scientific terms and concepts, not just general writing ability. For that media company example we discussed, this means using real current news articles and social media posts for evaluation, not just generic text scraped from the internet years ago.
Exactly. This ensures the evaluation is truly relevant to the model's intended use case and predictive of its performance in that specific domain.
Makes sense. And the fourth key strategy.
This one is more operational but crucial for efficiency. Adopt MLOps for generative AI tools. MLOps, which stands for Machine Learning Operations, is essentially the practice of automating and standardizing the entire AI development and deployment lifecycle. For evaluation, this means integrating your evaluation processes directly into your LLM development workflow, essentially automating the testing and validation steps.
Could you give an analogy for that?
Imagine a smart grading system that every time your student revises their essay, meaning every time you fine-tune your LLM, update its prompt templates, or change other components, it automatically runs all the necessary checks, calculates the metrics, maybe flags things for human review, and gives immediate feedback as a final step before the essay is published.
So it automates the quality control loop.
Precisely. It makes the whole process faster, more consistent, and much more efficient, eliminating many manual steps and potential errors. And if we connect this to the bigger picture, MLOps for generative AI ensures a continuous feedback loop. Every update to your LLM or its components is automatically evaluated against your key metrics. This is absolutely essential for ensuring not just initial quality, but ongoing usefulness, safety, and effectiveness, not just speed or accuracy on a static test set.
So while there's no single perfect way to evaluate every LLM for every task.
Right, there isn't. But adopting these best practices using multiple metrics, incorporating human judgment thoughtfully, using domain-specific data, and leveraging MLOps automation combined with staying updated with new research will help you continuously improve your evaluation methods and build more successful, reliable, real-world AI applications.
Okay, this is fascinating but also sounds intensive. Given these profound challenges and the critical need for rigorous best practices, where do people turn for help? Managing all this seems like a job in itself.
It absolutely can be. And this is where powerful platforms like Google's Vertex AI come into the picture. You can think of it as acting like your sophisticated AI grading assistant for these complex creative students.
A grading assistant, I like that. So how does Vertex AI fit in?
Well, think of Vertex AI as a central hub, maybe like a school administration system, but for AI. It's designed to help you manage all types of AI models, both the predictive ones we talked about earlier, who just give straightforward answers or classifications, and these generative ones, who create completely new things like text or images. It provides a single, unified platform to prototype, develop, train, evaluate, deploy, and monitor all your AI applications, aiming to streamline the entire machine learning lifecycle from start to finish. It helps bring all those complex components of the LLM lock the orchestra under one management roof.
Okay, so it's a unified platform. How specifically does it help with the evaluation challenges of generative AI that we've been discussing?
Vertex AI specifically addresses many of the challenges we've covered by offering built-in tools and services for several critical aspects of the generative AI workflow. It helps with selecting pre-trained models from Google and potentially third-party providers, giving you a starting point, like picking the best base curriculum for your student. It assists in optimizing configuration settings, allowing you to easily experiment with and tweak things like the temperature parameter, which controls the level of randomness or creativity in the output, so you can fine-tune the model's personality or output style.
Ah, controlling the creativity level.
Exactly. It's also crucial for harnessing prompt engineering. Vertex AI provides tools to manage, test, and deploy structured prompt templates to guide the AI's output more effectively and consistently. And importantly, especially if you're fine-tuning models on your own data, it helps in safeguarding fine-tuning. It includes tools and features aimed at checking for and addressing potential biases or safety issues in the training data or the model's outputs, helping to prevent the generation of undesirable or harmful content.
So it helps manage the whole process, including the safety aspects. Now, how does it actually do the grading? What are the methods?
Vertex AI offers two primary ways, or methods, to grade your LLM's outputs. These are like different approaches a teacher might use to assess an essay. The first is the computation-based method. We can think of this as the automated answer key check.
The traditional approach.
Pretty much. This method compares the LLM's generated output directly against a ground truth. That's the human-made correct answer or reference essay you provide using mathematical formulas or predefined rules.
So it's like a scanner that reads your student's essay and compares it word for word or phrase for phrase against a model essay you provided, quickly identifying overlaps or differences based on those programmed rules, like Rouge or BLU scores.
Exactly like that. The pros are clear. It's generally fast and efficient, and it's great for standardized academic and industry benchmarks where a single, well-defined correct answer or a close reference exists.
But the cons we discussed earlier still apply.
Yes, very much so. This method may not fully capture creative nuances or more subtle human-like qualities because it fundamentally relies on comparing against that single correct answer or reference, which, as we've said, is really hard to define or obtain for many open-ended creative tasks.
Right, like your automated grader might give two summaries, similar Rouge L scores, because they have similar word overlap with the reference.
But when you actually read them, one just feels much more natural, more insightful, or better structured. The numbers generated by computation-based methods don't always capture that subjective feel. So manual human review is still often needed to assess those subtle qualities that these automated systems might miss.
What kind of metrics does Vertex AI use here?
For specific tasks within this computation-based method, Vertex AI provides various standard metrics. For classification tasks like categorizing customer feedback, it uses metrics like micro F1, macro F1, and per class F1 scores. These basically give you a balanced view of the AI's precision, not making wrong classifications, and recall, not missing classifications, ensuring it's performing well across all categories. For summarization, a common metric offered is R-Varicella. The L stands for longest common subsequence. It looks for the longest sequence of words that appears in both the generated summary and the reference summary in the same order. It essentially checks if the most important sequence of words or core ideas from the reference summary is present in the generated one, trying to capture the essence better than just word overlap.
Okay, and how do you set this up in Vertex AI?
To use this computation-based evaluation, you first need to prepare an evaluation dataset. This typically contains pairs of input prompts and the corresponding human-written ground truths, for example, the ideal summary for a given article, or the correct classification label. Google recommends having at least 10 such examples, but ideally more, and they should reflect the kind of data and tasks your model will encounter in the real world.
Then you upload this data set.
Yes, you upload this dataset to Google Cloud Storage. Then, using Vertex AI tools, like the Python SDK, REST API, or the Web Console, you submit an evaluation job. You define the task, e.g. summarization, classification, specify your dataset location, point to the LLM you want to evaluate, and tell it where to save the results. Vertex AI uses automated pipelines, essentially pre-built automated workflows to handle the computation and report the metrics at scale.
Okay, so that's the automated answer key approach. But you mentioned a second, more innovative method.
Yes, exactly. Because of those limitations of relying solely on a single ground truth, especially for creative tasks, Vertex AI offers a model-based method. You can think of this one as having an AI teacher's assistant act as the judge.
An AI judging another AI.
Precisely. This is a more innovative approach, pioneered significantly by Google. It uses a specially trained LLM, what they call an arbitral model, or an autorator, to act as a judge. This autorator compares model outputs and assesses their quality, much like a human evaluator would, but automatically and at scale. Auto Side-by-Side, or AutoSxS, is a prime example of this powerful capability within Vertex AI.
An AI teacher's assistant. Tell me more. How does that work?
Imagine another highly intelligent AI program that has been specifically trained to understand what constitutes a good response for certain tasks. It reads, for example, two different summaries generated by two different LMs for the same article, compares them based on criteria like coherence, accuracy, and relevance, and then decides which one is better, sometimes even providing scores or explanations.
Wow. What are the advantages of that?
The pros here are potentially huge. First, it offers data-driven objectivity. While the autorator is trained on human preferences, applying it consistently across thousands of examples can reduce the individual human biases and inconsistencies you might get from relying solely on a small panel of human graders. Second, scalability and cost efficiency. It automates the often slow and expensive process of human evaluation, allowing for rapid, affordable evaluations on a very large scale. This is crucial when you're iterating quickly on models or prompts and need fast feedback. And third, potentially enhanced transparency. Some model-based methods, like AutoSxS, are designed to provide not just numerical scores or rankings, but also natural language explanations for their judgments, plus confidence scores indicating how certain the AI judge is about its assessment.
Explanations from the AI judge. That seems incredibly useful.
It really is. This helps you understand why the AI judge preferred one output over another, giving you much more actionable insights than just a score alone.
Okay, so we have computation-based and model-based evaluation methods. You also mentioned different evaluation paradigms in Vertex AI, how you actually structure the comparison.
Right, there are two main ways you can frame the evaluation task itself. First is point-wise evaluation.
Point-wise, meaning 1.1 model.
Exactly. This focuses on the absolute performance of one single model in isolation. It aims to answer, how good is this specific LLM on this task? It tells you how that specific LLM behaves, helps identify its strengths and weaknesses, and establishes a baseline for its capabilities.
It's like grading a single student's essay just to understand their individual writing skills and identify areas where they need improvement without comparing them to anyone else yet.
Precisely. The output in Vertex AI for a point-wise evaluation is typically a numerical score or a set of scores like accuracy, F1, ROGE, for that single model based on the chosen evaluation method, computation-based or potentially model-based against some absolute criteria.
Okay, and the other paradigm?
Is pairwise evaluation. This is all about comparison. It directly compares two models, or maybe two versions of the same model, or two different prompt templates used with the same model, against each other, to see which one performs better for a specific task or on a specific set of inputs.
So not an absolute score, but a head-to-head winner.
Often, yes. It's like asking a judge to compare two essays side by side and simply pick the better one based on overall quality or specific criteria, without necessarily assigning an absolute numerical score to either essay. The output in Vertex AI typically identifies the preferred model between the two, often expressed as a win rate.
And when would you use pairwise?
This paradigm is particularly great for practical decision-making. For instance, deciding which of two candidate models to deploy into production, choosing which set of prompt instructions leads to better results, or quickly assessing if your recent fine-tuning efforts actually made a model better than its previous version on real-world examples.
That makes sense. Okay, now let's zoom back in on Auto Side-by-Side, or AutoSx, in more detail. You described it as an AI debate judge for LLMs. This sounds like a key part of the model-based pairwise evaluation approach.
It is. AutoSxS is a really sophisticated tool within Vertex AI that uses that specially trained LLM, the autorator, to assess the quality of responses generated by other LLMs, typically in a pairwise comparison. Its main output is often a win rate, indicating how often one model's response was preferred over the other across your evaluation dataset. But the key feature, as we touched on, is that it aims to provide detailed explanations for its preferences and a confidence score for each individual judgment it makes.
It's truly like that advanced AI teacher's assistant that reads two student summaries, compares them based on learned criteria, tells you which one it prefers, and crucially gives you reasoned feedback explaining why it made that judgment.
That's a very good way to think about it. The autorator LLM itself is specifically trained on large data sets of human preference judgments to evaluate response quality based on various dimensions like helpfulness, relevance, accuracy, coherence, and safety. It's designed to be versatile. It can evaluate models that are registered within Vertex AI, or it can work with pre-generated predictions stored in tables, allowing you to compare, for example, Google's own Gemini Pro model against various third-party models in a consistent evaluation environment.
Does it know what good means for different tasks?
Yes, it uses predefined evaluation criteria tailored to specific common tasks. For instance, for summarization, it might focus on adherence to length constraints, coverage of key information, and groundedness, avoiding hallucinations. For question answering, it might prioritize relevance, completeness, and factual accuracy. This allows for more meaningful, task-aware evaluations.
Okay, so how do you actually use AutoSxS? How do you set up this AI debate?
The first step, like with computation-based evaluation, is to prepare your evaluation dataset. This is typically stored in JSON lines format in Google Cloud Storage or as a BigQuery table. Each row in this dataset represents one comparison instance and needs a few key things. Some ID fields to uniquely identify each example. The data fields, which include the original prompt that was given to the LLMs, and potentially any context that was provided, like the full article text for a summarization task. And, crucially, the pre-generated responses for the models you want to compare. For a pairwise comparison, you'd have a column for Model A's response and another for Model B's response to the same prompt context.
How much data do you need?
While technically the minimum is just one example, Google generally recommends using around 400 to 600 examples to generate reliable overall win rates and statistically significant results. This helps ensure your conclusions aren't based on just a few lucky or unlucky outputs.
Can you check if the AI judge agrees with humans?
Yes, and that's a powerful feature for building trust. You can include an optional column in your dataset indicating your human preference. Example, which response, A or B, a human evaluator thought was better. AutoSxS can then use this to report on how well the autorator's judgments align with human judgment.
Okay, data set prepared. What's next?
Once your dataset is ready in the right format, you then define the pipeline parameters for the AutoSxS job in Vertex AI. This involves telling Vertex AI things like your dataset location, the specific task type, e.g. summarization, question answering, the names of the columns in your dataset that contain the predictions for Model A and Model B, and optionally, you can configure the autorator's behavior further with specific inference instructions or providing additional context to guide its evaluation.
So you're telling the judge the rules of the debate.
In a sense, yes. You're configuring the evaluation run. After setting these parameters, you simply run the evaluation job. This initiates a pre-built pipeline job in Vertex AI that orchestrates the whole process, feeding each example to the autorator, collecting its judgments, and calculating the final results.
And what do those results look like? What are the debate outcomes?
Vertex AI provides the results in a couple of main ways. First, you get a detailed judgment table. This table shows the result for each individual example in your dataset. For each row, it tells you which model the autorator preferred, Model A or Model B, the autorator's confidence score for that specific judgment, and importantly, a natural language explanation outlining the reasoning behind that preference.
That granular detail sounds incredibly valuable for digging into specific failures or successes.
It is. It's great for debugging and understanding specific model behaviors or prompt issues. Second, you get aggregated metrics. This summarizes the results across the entire dataset, most notably providing the overall win rates, the percentage of times Model A was favored over Model B, and vice versa. This gives you the high-level comparison.
And if you included the human preference data,
Then you'll also get human preference alignment metrics reported. This shows how well the autorator's judgments matched your provided human preferences, often reported using metrics like accuracy, precision, and recall of the autorator itself compared to the human labels. This directly helps you gauge how much you can trust the AI judge's ability to mimic human evaluation for your specific task and data.
that trust metric seems really important. What are the main use cases for AutoSxS then?
The use cases are really compelling for anyone actively working with or choosing between LLMs. It's ideal for comparing different foundational LLMs, example, Gemini versus another model, to decide which is best suited for your specific application before investing heavily in one. Assessing if fine-tuning efforts actually improved a model's performance on real-world data compared to its base version. Optimizing prompt instructions, you can compare the outputs generated using different prompts with the same model to see which prompt consistently yields better results according to the autorator.
So it helps you make better choices about models and prompts backed by automated large-scale evaluation.
Exactly. AutoSxS represents a cutting-edge approach that promises to make evaluating the often nuanced and subjective output of creative or conversational LLMs much more efficient, objective, and scalable. It's a significant step towards achieving more reliable and trustworthy AI applications in complex domains.
Wow. Okay. What a deep dive we've had today. We've journeyed all the way from understanding the fundamental difference between predictive AI and generative AI, getting into the details of that complex orchestra that makes up an LLM system. We then really unpack those six profound challenges of trying to grade AI's creative genius, data issues, complexity bias, generalization, security, and subjectivity. We explored the diverse grading rubrics, the different evaluation types like binary, categorical, ranking, and the specific metrics we look for from Rouge and BLEU to groundedness and diversity. We examined best practices for making evaluation continuous and effective, like using multiple metrics and human judgment and the role of MLOps. And finally, you discovered how powerful platforms like Google's Vertex AI are stepping in to provide sophisticated tools for this, offering automated computation-based checks and innovative model-based methods like AutoSxS, acting as your AI grading assistant, or even that AI debate judge. So whether you're thinking about using AI in your work, maybe you're just curious about how these incredible systems are built and refined, or perhaps you simply want to better understand the technology that's rapidly shaping our world. Knowing how LLMs are evaluated, how we measure their strengths and weaknesses, seems absolutely crucial. It really empowers you to understand their true capabilities and also their very real limitations, giving you a much more informed and critical perspective as you interact with them.
Absolutely. And as these LLMs become increasingly adept at tasks we previously thought of as uniquely human, like writing poetry or composing music, and as we simultaneously build AI systems like AutoSxS to judge the outputs of other AIs, it does raise a fascinating, maybe even provocative question for us all to think about. What does this increasing reliance on AI evaluation mean for our own human critical thinking and judgment? Are we building systems that primarily augment and refine our judgment, helping us see things we might miss? Or are we, perhaps inadvertently, building systems that might eventually just replace our own critical assessment, especially in areas like creativity or subjective quality? And maybe more fundamentally, how much of our own subjective appreciation, our aesthetic sense, our discernment, should we or can we comfortably delegate to an AI art critic or an automated judge? Certainly a question worth mulling over as these technologies continue their rapid evolution.
That is a fascinating thought to end on, delegating our taste. Well, thank you for joining us today as we unpacked the incredibly intricate and important world of LLM evaluation. We really hope you're leaving with a clearer understanding, maybe a few aha moments about how these remarkable technologies are assessed and improved. Until next time, keep digging into what fascinates you.